So we didn't end up using t there, but I think that's okay. Cool.
So the other one was wrong then?
This is correct, but this isn't taking into account acceleration. So this is if it was spinning at a constant speed, then we could express theta in this way. But if it's spinning at a speed that's constantly changing, so there's acceleration present, whether it's speeding it up or slowing it down, either way, it gets a little bit more complicated and we have to figure out a way to work in that acceleration. So both of these are correct statements for different situations.
Okay.
Is there a part C?
Yes.
Assume that the motor has accelerated the wheel up to an angular velocity of omega 1 with angular acceleration alpha in time t1. At this point, the motor is turned off and a brake is applied that decelerates the wheel with a constant angular acceleration of minus 5a, or 5 alpha. Find t2, the time it will take the wheel to stop after the brake is applied. That is the time for the wheel to reach 0 angular velocity. Okay, use omega alpha and t. Okay. So, I would say we can probably still use that equation, but maybe not because we don't want theta. So maybe let's look at our third. Maybe we could use this one because it's got omega, alpha, and t. Those are the variables that it wants.
Yeah, it says some or all again.
So if we were going to try to figure it out using this equation up here, we've got omega 1 equals omega naught plus alpha times time. Oh, and we're looking for T2. So in this case, our final velocity, so our final omega that we're trying to get to is 0, because we want to slow it down to a stop. So really, to keep it consistent with what we've already done, this would probably be like omega 2, this is omega 1. So this is the speed that we had gotten up to in part A and B. But now we want to drop down from whatever that speed was, and we want to go to 0. So we want to say 0 equals omega 1 plus, and it says that now acceleration is negative 5 alpha.
Mm-hmm.
So let's go ahead and change this plus to a minus. And instead of just regular alpha, we'll say 5 alpha. And we are really okay, let's call this T sub 2. So yeah, I think that all looks pretty good. So now we just need to get T by itself. So to do that, we would have negative omega 1 divided by negative 5 alpha equals T2. Yeah, I think I feel pretty good about that. Does that make sense? Well, I guess I'll make sure it's right before we figure out why it makes sense. Did it not give it to us?
No. It says the correct answer does not depend on omega.
Correct answer does not depend on omega. Oh. I think they wanted you to use an omega sub 1. Because omega is not one of the ones that we're allowed to use. And I also want to use negative signs. Because really, negative divided by negative, we could simplify that and say omega 1 divided by 5 alpha. But maybe you should try that previous so Sam doesn't lose more points. Because I'm pretty sure that we were right all along. But yeah, it's just being picky about that subscript.
And it wouldn't be negative.
Well, I mean, it could be. We could write it either way.
Okay.
But just for, if we wanted to maximally,
Yeah, that's good.
that's right. So yeah, I'm sure that if you would have put a negative on both top and bottom, it would have given it to you as well. But if we're trying to reduce it to the most simple form,
Yeah.
this is less complicated than that. So yeah, just be careful with subscripts, I guess. Cool. So did that make sense? It was just figuring out which of our rotational kinematic equations had the variables that it was wanting us to express in terms of, and then getting the variable of interest by itself.
Yeah, makes sense now.
Cool. Is that all for the pinwheel?
Yeah.
Awesome.